As an operator, you may be required to operate many types of heat exchangers. Since shell and tube heat exchangers are one of the most common types of heat exchangers, you need to be familiar with their components and operation. We'll use this illustration of a shell and tube heat exchanger to explain how it works. The main components include a shell, a group of tubes called a tube bundle, tube sheets, and heads. The shell is the casing of the heat exchanger. The area inside the shell and outside the tubes is commonly called the shell side of the heat exchanger. The shell also has an inlet and an outlet. The tubes are used to create a separate flow path through the shell. Each end of the tubes opens into a head. One head directs flow into the tubes, while the other head directs flow out of the tubes. The area inside the tubes and heads is called the tube side of the heat exchanger. The heads also contain a tube side inlet and outlet. The ends of the tubes are supported by the tube sheets. The tube sheets also isolate the heads from the shell side of the heat exchanger. The tubes are supported inside the shell by partitions called baffles. The baffles also direct flow through the shell side of the heat exchanger, which helps increase the efficiency of the unit. Here's how this heat exchanger works. During operation, the cooler fluid enters the shell, flows around the tubes, and leaves through the shell outlet. On the tube side, the hotter fluid passes through the inlet head, through the tubes, into the outlet head, and leaves through the tube outlet. As the hotter fluid passes through the tubes, it transfers heat to the tubes and the fluid on the shell side, so the temperature of the fluid flowing through the tubes decreases. On the shell side, the cooler fluid passes around the tubes and receives heat from the tubes, so its temperature increases. This is a simplified illustration of a distillation system. The heat exchanger in this system is used to cool the process liquid so that it can be stored safely. In this system, a distillation column is used to separate a product from a process liquid. The product boils off and leaves the top of the column. The remaining liquid is pumped from the bottom of the column. The hot liquid passes through the heat exchanger and transfers some of its heat to a coolant that flows through the shell side of the heat exchanger. The cooled process fluid is then sent to a tank where it's stored. In this system, the heat exchanger is used as a heater. The process liquid that's pumped through the heat exchanger tubes is heated by steam that flows through the shell side of the heat exchanger. The heated liquid is then sent to a process reactor. In the reactor, additional materials are mixed with the liquid, and a chemical reaction occurs. By heating the process liquid, the heat exchanger enables the chemical reaction to take place more efficiently. In order to get fluids into and out of a heat exchanger and make sure that heat transfer occurs efficiently, some auxiliary components are needed. These auxiliary components include valves, instruments, and steam traps. There may be many different valves used with a heat exchanger. For example, isolation valves may be located on a heat exchanger's inlet and outlet. They're open to place the unit in operation and closed to isolate the unit when it's taken out of service. Many heat exchangers also have drain valves. These valves are used to remove fluid from the heat exchanger when the unit is shut down. Vent valves are also found on heat exchangers. Vent valves are used to remove air or other undesirable gases from heat exchangers. If pockets of air or gas are trapped inside the unit, they can prevent process fluids from coming into contact with some of the tubes. When this happens, the heat exchanger won't be able to transfer heat properly. These pockets reduce the heat exchanger's efficiency and can produce hot spots. A hot spot is an area in the heat exchanger where temperatures become excessive. These areas of high temperature can damage the heat exchanger. Another valve that's commonly found on a heat exchanger is a relief valve. Relief valves are used to prevent overpressurizing heat exchangers. If the pressure exceeds a preset limit, the relief valve opens to relieve the pressure. The relief valve will remain open until the pressure falls below the preset limit. Another type of valve that is commonly used with heat exchangers is a control valve. Control valves are used to regulate the flow of fluids through heat exchangers. For example, the flow of the heating or cooling fluid is often regulated to control the temperature of the process fluid leaving a heat exchanger. In this system, the control valve is linked through an instrument system to a device that senses the outlet temperature of the fluid. As the fluid's temperature changes, the sensing device sends a signal through a controller to the control valve actuator, which opens or closes the control valve and regulates flow to maintain the desired temperature. Generally, an operator can observe instruments to determine if a heat exchanger is operating properly. These instruments are often located in the control room, but they may also be found on or near the heat exchanger. Depending on the heat exchanger and its use, pressure and temperature gauges may be placed on any or all of the heat exchanger's inlets and outlets. On heat exchangers that use steam, an auxiliary device called a steam trap is often used. The steam trap drains water or condensate from the steam in the heat exchanger without letting the steam escape. Lost steam reduces the efficiency of the heat exchanger.